Okay, in this video we're going to take a look at what is domain and range, or maybe more appropriately we could call this what are domain and range. So let's start off with a couple of definitions. So the domain is the inputs, the x values that you can put into a function, so the inputs for which a function is defined. And by that I mean that there is some sort of an output, usually a y value as an output. The range is the possible output y values for that function. Now, actually technically these can be relations as well. However, most of the things that we'll see in these courses that I'm teaching you are functions. So let's try to put this a little bit more graphically. You start off with some x value and you put it into this function. And the function has some sort of a definition. It tells you what to do with your x values, and then it spits out an output. So it's a little bit like a machine. For instance, if we tell, if we're working with the function machine that takes x values and doubles them and then adds 1, this is the rule that this follows. This machine just follows, or this program just follows this rule. So for instance, you take this x value, you put it into this equation, and out comes a y value. So you take 2, you put it in, 2 times 2 is 4, plus 1, so you double it and then add 1, and you get an output value of 5. And you just keep doing this. So if you put in 0, you get out 1, and if you put in 10, you get out 21, and if you put in negative 10, you get out negative 19, etc., 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 etc. You just can continue doing this for as long as you want. And what you'll notice if you do this forever is you can actually put any value at all you want in for x. And when you do that, you'll get output values, but those output values can actually be any number at all for y. And so this will be your domain, and this will be your range. It's actually nice to see this graphically as well, so I'll just do a quick little sketch here. This graph is a linear function with a slope of 2, so it looks like this. And what I'm saying is in the x and the y direction, what input values, can you input 0 and get a point? Can you input 1 and get a value? Can you input 2 and get a value? How about some of the negatives? Can you extend this to negative 1,000 and get a value somewhere way down there? And you can. And so you can actually input any x value at all, and that's what this domain statement is saying. You can go ahead and input x to be any number at all. And likewise, you can get output numbers of any y values at all. You can get an output of 0, it's right here. You can get an output of 1, you can get an output of 2, you can get a y value of 3, or you can get y values into the negatives, and they go on forever. So we state that as y can be any output value as well. Of course, if we change this original function, this original rule, we possibly change the domain and the range. So let's take a look at another example. What if we have that we're going to square the x value? Well, now when you take your x and you square it, that becomes your y. So when you take 0 and square it, you get 0. When you take 1 and square it, you get 1. When you take 5 and you square it, you get 25. And if you start taking some negative numbers and squaring them, you get, negative 1 times negative 1 is positive 1, and negative 100 times negative 100 is a really big positive number. And again, looking at this as a graph, it looks a little bit like this. This is our y direction, this is our x direction, and there's 0, 0, and some other points. Now maybe we can see what x values are we allowed to put in, and yet again there's any value of x is allowed to be put in. So you can input anything you want into here. There's no restrictions. However, the outputs are not quite the same. In fact, you can get 0 as a y value, and you can get positive numbers as y values, but you'll have a hard time finding any y values that equal -1. You'll never see -1 or -2 on this right-hand side as y values, and that's because the y values will be 0 and bigger. So for my range, my y values are going to be bigger than or equal to 0, but they're all numbers bigger than or equal to 0. And it might seem like all numbers is a bit of a contradiction to numbers greater than or equal to 0, but these two things are combined together. So it's all the values greater than or equal to 0. If I just say numbers greater than 0, you don't know what kind of numbers greater than or equal to 0. Is it just even numbers? Is it whole numbers? Is it multiples of 10? So this last statement tells you that it's in fact any kind of number greater than or equal to 0. We don't always need a equation. In fact, we can do this just from some cool looking pictures. So let's just do a couple of examples with just the graphs shown. So here's a couple of graphs. This one has what's called a horizontal asymptote at y equals 2, and so the y values get closer and closer and closer to 2 but never get there. So let's take a look first of all at what input values can we have. What x values are we allowed to put in and get a result for? So I like sometimes just checking it. Can you put in 0? Yep. There's a point right there. Can you put in positive numbers? Yep. That all looks good. Can you put in negative numbers? Yep. That all looks good as well. So again, x can be anything. But in my range, I can only have y values. I can't get y values above this asymptote. There's just no graph above the asymptote, but I can certainly get y values below the asymptote. So I can have y values less than, but not equal to. It never gets to the 2, and of course it can be any value less than 2, but not equal to 2. There's another way of stating this, which is you can say that the domain goes from -infinity to +infinity, and the range goes from -infinity up to 2, but not including 2. So this bracket that's curved means doesn't include, and since you can't ever get to infinity, you can't include it. And I'll show you what that looks like on this next one. So this is just an interval notation for domain and range. For the next one, domain, well, now my x values, I can have 0 and I can get some positives, but I run out of positive graph at 5. And likewise into the negatives, I can't go below -5. There's just no graph there. So the x value can be bigger than or equal to -5, bigger than -5, or equal to it, and less than or equal to 5. And so it's basically between here and here, where that red line is, and it can be any number in between there. You get a 0, 1, 2, 3, -1, 2, 3, they all work. And if I use the other notation, I'm saying I can go down to -5 and I can go up to +5, and these square brackets means and it includes those points. So I can actually get to -5 and I can get to +5. In the range, I'm really looking at these y values, which are from -2 to 2. So I say, okay, y is bigger than or equal to -2, y is less than or equal to 2. I make it one complete statement, and it's any number at all in there. If I like using interval notation, I say it goes from -2 to 2. So there's a quick overview of domain and range. I'll see if I can find some more practice and put a link into it in the description or in the YouTube comments below.